Hello, Mark Palmquist again. On this video, I wanted to go through the top 10 books that I recommend if you want to learn how to design a boat or learn how boats work. The first one is actually not a book, but it's a scientific paper. It's if you want to know about hydroplaning and the science of hydroplaning, most of the research was done in 1964 by people involved in naval testing in the United States. The most famous is a guy named Savitsky. And even though most of his research was done and testing in water tanks was done in 1964, a lot of the information and the data and the formulas that he came up with for predicting the speeds and the drags related to different shapes and different dead rise angles and different angles of attack are still relevant today. So he developed a method, and a lot of that has been put into computer programs for fluid dynamics assessment. All right, and then these books are going to be in chronological order, so we're starting way back. This is just a fluid dynamics book by Bender. This is where I learned the formula for water hitting a plate or a fluid hitting a plate at an angle, which is basically what a skimming surface does. And there's also a formula for a fluid hitting a curved vein, which is really interesting as well. So you need one book on fluid dynamics. It doesn't have to be this one, it could be any book really. All right, so this is a book by Marchaj. That's how you pronounce his name, Marchaj. He did a lot of empirical testing, water tank testing. This book was published a long time ago, but at the time it was like way ahead of its time. So this is also 1964, but I guess it was edited in '82. But the reason I like this book is because it just touches on everything, and it's written in a way that's easy to draw conclusions. A lot of scientific books and literature, they give you all this formula and then they don't tell you what it means. This book has a good combination of formulas and then explaining what to deduct from seeing and understanding the formulas. This is a really good book on multi-hulls. It's by Chris White, The Cruising Multihull. I have 3 books on multi-hulls, but this one was the best balanced book. It has a good balance between, some science, some formulas, and a lot of practical information in here. And trying to see here when it was written, looks like 1972 maybe. I can't see the copyright. But again, the problem with this book is it doesn't incorporate everything that has happened since 1972. So I've been waiting for somebody to come out with a book, a multi-hull book, design book that has more information. Okay, so that's a good book. These books are basically equal, in my opinion. They both came out about the same time. This one's Hydrodynamics and 2009. So these books introduce all the formulas, all the methods for calculating the speed potential of mostly monohulls. It goes through drag and sail camber and all kinds of stuff like that. It talks about riding moment. It talks about heeling and pitching and yaw and how to minimize those, and what is a good shape for a dagger board. And my biggest criticism of these books is it tells you what the prismatic coefficient is, what the definition is and how to find it out, but then it doesn't really say, okay, so if you want a boat that goes this fast or travels in this speed range, then your prismatic coefficient should be X. It doesn't really go into that. So it's like you learn a bunch of stuff and then you still have a bunch of questions. Like if I was in a lecture with these guys, I would be raising my hand constantly and asking them questions. So they give you a lot, but it's almost like they're holding back all the nuggets of gold. And that just kind of rubbed me the wrong way when I read these books. It's almost like they didn't disclose all their secrets, and they could have. The book would have been bigger, but it would have been a whole lot more useful. Here's a nice book. Came out at about the same time as these two books. Float Your Boat by Mark Denny. This is a well-rounded book. It goes through, it touches a little bit on some faster boats, hydroplaning. It's not as comprehensive as the other two, but there are some things in this book that I learned that weren't in any other book. If you can get one or two little nuggets that you can't find anywhere else, in my opinion, it's a good book. So it's worth reading. Okay, so here's another good book, Multihulls for Cruising and Racing by Derek Harvey. So it doesn't have a lot of science in it, equations and stuff, but it does have very good explanations of, so here's a formula, but it does have a lot of explanations, this is good, that's bad, and why, and talks about asymmetry and hull shapes, and how certain hull shapes, cross sections are better than others, and so this is a really good book as well. It's worth reading. Okay, so now are we in the 21st century yet? Let's see, what is this? No, oh yeah, here we go. All right, we're finally in the 21st century. 2009. So this was at least 13 years ago or so, 14 years ago. This is a really good book. If you want to learn about hydrofoiling, this is a really good book. He does not talk about hydroplaning, so there's no comparison. He doesn't compare hydrofoiling with hydroplaning, except I think there's like one little statement that says that hydrofoiling is more efficient. Anyway, the other thing is he doesn't really talk about specific shapes and what are the specific shapes that produce the best results of, like what foil cross section should you use if you want to design a boat for low speed, and then what cross section should you use if you want to design a boat for higher speed. He doesn't really go into that. So it's another one of these books where you read it and then you still have all these questions. Like, okay, well, give me something practical. It's worth reading. It's just another one of those books that it could have been better. It could have been a little bit more specific. But without having this book, there would be nothing really on hydrofoils. Okay, this up to last week was my most favorite book, because this book is jam-packed loaded with scientific data. it has formulas, but it's mostly data, like testing, like drag testing, hull testing, all kinds of testing, and he actually does give a lot of practical advice, like keep your foils vertical, your dagger board and your rudder, keep them vertical, and stuff like that. And this is the first book that it kind of talked about whether or not a boat can go faster than the wind, and how much faster, and why. This book was the first book to explain how you can go faster than the wind. But again, it kind of mainly covers hydroplaning skiffs. It doesn't go into foils. It doesn't really go into anything else. And there is one experiment where he had a somewhat hydroplaning float on it, and then but it was extremely low aspect ratio, and anyway, they kind of decided that wasn't needed, so they put wings, long hiking wings, and put trapeze on this boat. Anyway, you're going to learn a lot from this book. There are some things in this book that are not current anymore. Like he states that a windsurfer cannot go faster than the speed of wind, and that's actually what I believed until I picked up this book, which just came out a week ago. Yes, this book came out. The copyright date on this book, Performance Calculations Methods for a High-Speed Sailing Craft, Malcolm Barnsley. This is the guy who designed Sailrocket 1 and 2, Vestas. And this is now my favorite book. Anyway, in this book, he says that you can see charts, and it shows that windsurfers and kite surfers can go as much as 1.3 times the speed of the wind. But this book, what I learned from this book is that if you tack downwind and you can maintain either hydroplaning or foiling, your distance made good is higher. In other words, this is the first book where it says don't sail directly downwind, go downwind at an angle and keep angling, like zigzagging, just like you're tacking upwind, and you're going to end up going faster. Of course, it also introduces the asymmetric spinnaker, which is a development from Australia, and the 18-foot skiff, the open skiff. It's a design category where basically there's no limit to the width of the boat. It's only limited to the length, and so that's why they kept creating these longer and longer hiking wings, because the pole does not, it doesn't count for the length of the boat. They just kept adding these longer and longer poles in the front of the boat so they could get a bigger downwind asymmetric sail. So the reason this works, a complete downwind spinnaker doesn't really work, because this actually works better. So it has much deeper camber than a regular upwind sail, but because you're not going directly downwind, you're kind of tacking away from the wind. This kind of sail works great on really any kind of boat that can hydroplane or hydrofoil. So this is a very good book. And then I just got this book literally Friday. It just came in the mail. This is now my favorite book. If you want to design a boat and you don't have time or money to go to naval architecture school, like I don't have time for that right now. I spent 7 years in college already. So this book has a really, really good balance of formulas, science, and then explanation and a simplification of all the concepts. And this touches more concepts than any other book. This looks at the relationship between the dagger board and the sail, and how you can't have one without the other, and thrust is basically a product of the two, the sail and the dagger board. And then towards the back of the book, I still haven't read the whole book. I've just read about half of it in the last 4 days. But I highly recommend this book. I'm not being paid by Malcolm Barnsley. The funniest thing about this book is the first couple paragraphs. There's a typo one typo on each page, and then by the middle of the book, there's a typo in each paragraph, and by the last couple chapters, every sentence has a typo. It's hilarious. But I was able to figure out what the intended spelling and meaning was. So anyway, go out and get this book. It's worth it. If you only had to buy one book on high-speed sailing craft, it would be this one. I've learned so much in 4 days just from reading this book. I had plotted all the speeds and the riding moments and the sail areas and the weights of all these boats, and there were 2 boats that did not fit. Their speeds were either way too high or way too low, according to all the other boats. And I was like, what is going on? Why is that? So a windsurfer did not fit in my speed chart. I created a simplified formula, and according to that, the windsurfer should have a top speed of 22 to 25 miles an hour, but it doesn't. It goes 55 knots. So this book, it touches on the reason why. And so there's something called the lift to drag ratio, and you can have different ratios, and you can have high lift, high drag, and you can have low lift, low drag, and you can have medium lift and medium drag. And this is the first book that talks about that in any kind of meaningful way. And so that explains the speed of a windsurfer. I was like, why? How come the windsurfer has such a high sail area to its riding moment? Wouldn't the windsurfer just blow over? The answer is the windsurfer, the sail operates at smaller angles of attack. So the sail is higher strung. It has less camber, less curvature, and everything about the windsurfer is low drag. So you have low power in the sail, and you have low drag. And when you think about that, what does an airplane do to cruise at cruising speeds? It reduces the curvature on its wings so that it has lower drag and lower lift. And when it's landing and taking off, it increases the curvature on the wing. So once you move into a higher speed range, it kind of makes sense that you kind of you lower the camber on whatever the lifting surfaces are, and you lower the drag. And those two things explain why windsurfers go faster than 25 knots. They go 55. But anyway, I'm still learning a lot from this book. There's so much to take in. It gives me a lot of ideas. I've already my head has been flooded with ideas, like new designs, configurations, especially for a land yacht. Okay, so here's one more book that I wanted to go over. Now, this book has a lot of math. It goes through all the theory and the math and the calculations and the formulas, and then it has a series of examples of foil shapes, and it has these fancy charts and graphs. But the book does not do a really good job of explaining what to look for in these graphs. And so the practical knowledge, you basically have to be an engineer to understand this book. And I'm halfway an engineer. I took 2.5 years of engineering classes. I never got a degree in engineering. So technically I don't have a degree in engineering, but even though I took statics, dynamics, I took 5 calculus classes, I took fluids, I took dynamics, differential, def bods, the physics of deformable bodies. I took a lot of stuff, but this is the thing that caused me not to want to be an engineer. Is engineers, they get lost. They don't, like, in other words, an engineer can understand this, but can they take this knowledge and apply it to the real world? That in my opinion is the difference between a designer or an inventor and an engineer. And so, although this has a lot of useful information, they don't give you the code. They don't tell you how to decipher it. They don't, I mean, they could have done that. They could have said, okay, you want a foil that's good for low speed? Pick this foil. You want a dagger board that is gonna work really good at high angles of attack at low speeds? Pick this dagger board shape. You want to design a boat that's going to go over 50 knots? Pick this shape. They don't go into that, and that really bothers me. So anyway, after reading this book and how nice it was to have explanations and, okay, so this is a formula, but this is what it means. It just proves that people can do better when they're writing a book. If you're an engineer and you know all this technical stuff, please create some kind of key or way of explaining it so that people can use, people that aren't professors can actually, get some useful information out of the book. Anyway, that's my 2 cents on this book. Every once in a while I pick it up, and I hope that I can, kind of break that barrier, basically. But yeah, I mean, if you want to find out the shape of the fin used on a windsurfer, you have to Google it, and there it is. It shows up on AI. AI tells you that, and then I looked up the foil, and here's the foil. But this book is not going to tell you that. So anyway, and how did people arrive at picking that foil? Is because it had certain characteristics. It had certain relationship between the speed and the drag and the when the foil cavitates and all that kind of stuff, and the angle of attack, and what is the lift at the different angles of attack. And this book could have explained all that, but it doesn't. So anyway, could have been better. I hope somebody comes along and creates a book on foil shapes that includes everything that has happened in the last 30 years. Because there's foil boats everywhere, and I still can't figure out what foils are they using. It's like nobody's explaining that. Anyway, this book has a picture of the foil that they used on Sailrocket 2. It actually shows the foil, and it's relatively an accurate drawing of the foil. That's one of the reasons eventually I want to write a book. I want to take all this stuff that I've learned and basically put it in a book in a way that makes sense to people, and that's why I started making videos in the first place, because the people that design monohulls, they know nothing about how the behavior of a multi-hull. And the people that design multi-hulls, they don't really know much about monohulls. Everybody is like focused on one thing. Like, you either design catamarans, that's all you do, catamarans, 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 or you do trimarans, trimarans, trimarans. There aren't a lot of people, I mean, all of these books, there aren't a lot of books that touch on every single thing. And this is the closest book that touches on everything. It touches on the monohull, it touches on multi-hulls, proas, asymmetric proas, canting of the sail. Anyway, so you got to get this book.